Hello, and welcome to Bioactive. Today we'll be doing a series of 5 videos. This first video we'll be talking about the auditory system. So we'll be talking about how the sound travels through the ear and gets communicated to the brain of what you're hearing. So let's talk about first the sounds. Sounds have a lot of different variants of energy, and this will either increase the length of the wave or decrease it. So when you hear something, first it goes into your ear and strikes your tympanic membrane, which other people call the eardrum. Once it strikes it, it causes a vibration, which causes the malleus, a bone, to vibrate, which also is connected to the incus, which is also a bone, which vibrates, and vibrates the stapes, which is also another third bone. So you have a total of 3 bones within the middle ear, and these all vibrate. The stapes vibrates and hits the oval window of the cochlea, and then within this cochlea we have a fluid which helps conduct or capture the sound waves that are being produced. Now at the beginning of the cochlea, as it gets wrapped around in kind of a spiral, we have a high frequency, and then as you continue into the spiral you get lower and lower frequency. So usually as you increase in age, what happens is the hair cells that are in the cochlea get broken first and the higher frequencies. So as you get up in age, your higher frequencies you will not be able to hear. So back to the sound in the cochlea. As the waves hit the fluid, it creates vibrations again. These vibrations actually cause a tectorial membrane to move up and down, which contacts the hair cells. Now the hair cells will be kind of like a Morse code, so when it gets touched it will send a signal all the way up to the brain, and the brain will interpret as a sound. Wherever these hair cells will be lying on the cochlea, that's what signal will be sent to the brain. So for example, sound comes in, hits the tympanic membrane, then hits the 3 bones, they all vibrate, which hits the cochlea, which vibrates the liquid inside the cochlea, which hits the hair cells within the position that they're located. Higher frequencies first beginning, lower frequencies at the end. As the sound wave leaves the cochlea, it hits the round window, which dampers all of the sound, which allows more of the sound waves to enter into the fluid. You have also muscles within the middle ear, which dampers the sound. These muscles are attached to the 3 bones, so when a big sound comes or a really high energy sound goes into the tympanic membrane and hits these bones, which we talked about before, the muscles tighten and damper the sound. So for example, a aircraft overhead goes over and you hear this big sound like boom. For a moment it will be dampered and it will lessen the damage caused on the hair cells. Within the vestibule we have what's called the macula, and when the fluid moves within the vestibule, the macula will shift, and this will give you a sense of if you're facing a certain direction. It will give you the up and down movements. Also within the semicircular canals we have the cupula, which when the fluid moves it rotates these kind of finger looking things, and this will give you also a sense of rotation or position. Both of these together will give you an idea of where you're moving, how fast you're moving, if you're going up or down, or if you're being spun around or rotated. So it'll give you the orientation of where your body is according to the orientation of where you're standing, according to the earth, or whatever plane that you could be standing on. And thank you for watching Bioactive once again. Please rate and subscribe, and check out other things on our channel, and leave comments down below for any videos that you would like to see. And thank you for watching Bioactive.